Yeah, yeah. Good day, everyone. My name is Engineer Shehu Isa Adebisi. I'm the lead structural engineer for Siafat Consult. And you are welcome to the YouTube channel of Siafat Consult, whereby we train structural engineers that are working already. We train young graduates, and we train them on design of reinforced concrete and steel structures. And we are not teaching software, but we are actually teaching the nitty gritty and the basic understanding of structural designs. So you, we have actually been seeing comment from my team. So my team has been telling me that we have people that are watching our content, that are watching our videos on YouTube. At least we have up to like 70 to 80% of people that have watched our content on YouTube's, that have watched our structural engineering videos, but have not subscribed. So I would like to implore you to subscribe uh, to the YouTube channel of Siafat Consult, and it promises to be worth your while. You are not going to regret it. So like I've said before, the two softwares that we're using is Start Pro and Data Structure. Yeah, so for today's topic, I'll be explaining in detail the concept as regards why we hinge our beams. Yeah, so why do we hinge our beams, and what is the implication on the analysis output of the structure? So like I said, if you have not subscribed to the YouTube channel, kindly give it a thumbs up. So when we release videos, you will be getting notifications on the videos that has been released. Now let's proceed to the training. Like I said, I want to explain the concept on engine of um engine of beams to you guys. So some people have been asking questions that why do we hinge beams? Why don't we hinge beams? This, that. So I'm gonna use this video to explain it to you guys in detail as regards why we hinge beams. Okay, so let's go to the plan view. So I have these three structures now, these three models rather. I have A, so let's call this one A, let's call this one B, and let's call this one C. Are we there? Okay, in order for us to not forget, so let me do it like this. Okay, let me just try and snip it. Yeah, okay, I think it's so I want to be able to capture the tree. Okay, I think it's better like this. So let me snip, yeah, let me snip it. So I'll be able to I'll be able to tell you which one is A, which one is B, and which one is C. Okay, so let's snip it. Okay, so so this is A, right? This is A, this is B, and this is C. Okay, so now for A now, I have a model in which I hinged the two ends of the support, which is the way that we actually hinge. Because for a pin connection, um, a moment is actually not being transferred to a pin connection. You get so, and the moment is usually not being transferred at the ends of the support. So as you can see that I've already hinged these two beams. I hinged the start and I also hinge the end. So this is what option A. For option B, I didn't hinge any of the beams at all. So this is option B. Now for option C, we actually do this when we actually designing steel structures. yet it still is not a reinforced concrete structure. So we design it when we're designing. So we use this when we're designing a steel structure. So for this, I hinged all the support. Yeah, I hinged all the support. Please, we don't do this when we are designing for reinforced concrete. We do not do this. We do not hinge support at the middle. We don't hinge the columns for if the beam is continuous. We do not hinge columns at the middle. I'm just trying to explain the concept of hinging to you, so you guys can be able to understand this in details and in total and have a good understanding of it. So this one is being done when we actually designing the steel structures. I'm going to explain the implications of this to you. Now, I've I've run the analysis of this. You can see that I've already run the analysis of this. You can see that the main analysis is green. So now let's now proceed to the analysis result. Then we will make comparison of these guys as we actually proceed. Now for A now, for A, let's go to the analysis result for A. Now let's click on this. Let's click on this. So let's go to section. So let's go to diagrams. So now you can see this is the analysis result for A. I need you to pay close attention at the span moment, and that means the sagging moment and the hugging moment. So the sagging moment for this is 58.6. The hugging moment you have 72.3, and you also have 94.6 and 91.6 here. And you can see these are the values of the moment that we have. These are the values of the moment that we have. These are the values of, and I also need you to pay a close attention to this. Let me explain what I'm saying. I'm coming here. Let me I'm coming. Let me snap this so I'll be able to actually give you a detailed explanation of what I'm talking about. I want you to pay very close attention to this, so you will be able to have a full grasp of why we actually hinge our beams, why we hinge a structural element. So okay, so that is that. Now I'm doing this because I want to snip this also. So let me snip this now. Are we there? So let me snip this. Right? So remember, this is for A. This is for A. Now I need you to pay close attention for to option A in this place. Right? I need you to pay close attention for option A in this place. Now you can see that I do not have any moment at the support here at the beginning. Now remember that I hinged the columns at the support at the beginning. So I do not have any moment here. You can see that the moment here is 0. I also do not have any moment here. And look at the values of my sagging moments and my hugging moments. Can you see? Now this is A, right? Okay. So let me copy this. Yeah, yeah. So let me copy this now. I want to bring out and let me save this here. Let me save this here. Please, I need you to pay very close attention to this. This is actually really very, very important. It's actually very, very important. I need you to pay very close attention to this. Okay. Okay, the WhatsApp is loading. So let's proceed. So you can see what we have here, that we do not have any moment at the support here, and we also do not have any moment at the support, and we you can see the values of the bending hugging moment and the sagging moment. So let's close this. Right, now let's go to the second one now. Now remember that I didn't inch any of the columns, any of the beams rather. I just left it the way it is. Can you see? So for this now, let's look at the analysis result of this. Let's look at the analysis result of this. So now let's go to the bending moment and shear force diagram. Now you can see this now. You can see this that you can see that we have a reduction. We have a slight reduction in the sagging moment of this. You can see that this one is 54.7, right? Now let's see that of this. That one I was trying to copy the other time. Okay, so this one is what? This one is you have that one is 54.6. So here you have 58.6. But for that one, you now have a moment at the support now. You have a moment over the support. Why? Because it wasn't hinged. So the engine negates moment. It doesn't transfer moment to where you hinged. Because the default setting of the software is that the structural element, the beams are fixed. So you as the designer will not be the one to determine how your structural elements are actually going to behave. So you now say, okay, I want this to transfer moment here. I don't want it to transfer moment here. I want this. I want this. So you can see that this one is what 58.6, right? And this one is what 72.3. But let's see what we now have. You see, this one is what 54.7, right? So here you can see the value of the hugging moment for this one is 70.7, but the value of the hugging moment for this is what 72.3. Then here you have 91.6, 94.6. So you can see that there is a reduction in the values of this moment. You see this one is 73.8, right? Let's see the values of this. This one is 79.2. So you can see that there is a reduction in the values of the moment compared to when it was hinged. So, and this one is actually having moment at the support here. You can see that there's a moment here. See, okay, let me zoom in. You can see that there's a moment here. You have 7.9. And you can also see that there is also a moment here, 11.1. You can see that you can see the way the moment is now being distributed for fact that it is fixed, it is not hinged. So you can see the difference. You can see that we have a reduced hugging moment and sagging moment, but we have moments here at the support here, and we also have moment here at the support here. So you can see the two differences between A and B, right? You can see the two differences between A and B. So you can see the two differences between A now and B now. So let's go to C now. Now, this thing, like I said, the C, you do not do the C for a reinforced concrete structure. We do the C for steel structures. That is when we want to design, do the structural framing, and we want it to be a pin connection. That is when we do something like this, whereby you do moment release or you pinch the columns, the beams at the middle. That means the intermediate beams. You hinge it. This is not done in a reinforced concrete structure. I repeat again. Now, now let's look at the analysis result of this. You can see that I have hinged the columns, I've hinged everything. So let's look at the analysis result, the beams rather. So let's click on this. Now let's go to diagrams now. Yes, very good. So you can see that my engine of it has turned the beam to three simply supported beams. Can you see that it is no longer a continuous beam because you do not have any hugging moments. It has turned it to like three separate simply supported beams because I inch. And if you look at the values of the sagging moment compared to what we had, let me show you what I'm talking about. If you look at the values of the sagging moment compared to what we had, you see that we have 58.6, 34.4, 79.2. Now, but when you now look at me now engine these ones now at the support now, you see that that is not transferring a moment at the support. Can you see that the support is not generating it? Why? Because I hinged it. That means that I want the beams to behave as a network of simply supported beam. Why? Because I want it to be a pin connection. Are we following? So now, now see this one now. This one is giving me 86.4, right? Now see the values that this one is giving me. This one is giving me a moment of what? 58.6. That is actually the way I actually want the structure to behave, because I actually inch the intermediate support. I repeat again, don't do this for a reinforced concrete or structure. Do it for a steel structure. So now let's now compare the reinforcement details for this. Now let's go to I want to show you guys something. I have a spreadsheet here. That I use for that I use I hope okay my Excel is not sure if it's actually like it's actually working, but let's see. But I believe I believe you get the concept of what I'm actually trying to do. I believe you get the concept of what I'm trying to do here. Of what I'm actually trying to do here. Yeah. Okay. So let me see what we can do here. We have 50. Okay, very good. Very good. Now let's look at this one. Let's see the value of this. Okay, we have 58.6 here. So let me put the moment 58.6 here. 58.60, right? Let me see the area of steel that is. It's giving me an area of steel of what? 195 millimeter squared. So for me to get an area of steel of 195 millimeter square, so let me change this to 16. Okay. Okay, for 195, that means I need to use, okay, so I have 230 by what? 230 by 600, right? Okay, let's do it like this. Now, the area of steel that I require for the first one is 308. I need an area of steel of 308 millimeter square. That is for when I didn't inch the intermediate support, right? Now, see this one here now. If you look at this one here now, where is it? Okay, so let me see what we have here. Let me go to the diagram and let me see what we have here. Yeah, so for this now, I have 86.4, right? So let me see what the area of steel for 86.4 is actually going to be. So let me put 86.4, 86.4 here. Okay, so you see, I have an area of steel of 465. So that means that there's a possibility. It's not even there's a possibility. That means I'll be using more steel there because I'm having 86, while that one is actually 54 for the moment. So, that is just a brief explanation on the concept of engine of reinforcement, right? So, this thing, like I said before, this one, the two supports at the end was inch. This one, none was inch. And this one, everything was inch to just to explain the concept as to why we inch beams. So, and I've already shown you the analysis result. And this one that is not inch is actually going to induce a moment on the support here. This one is also going to induce a moment on the support here, right? But this one that is inch, the engine is saying that you do not want a moment to be transferred to that point, right? You don't want the moment to be transferred to this place. That's why it's being inch. You don't want the moment to be transferred to this place. So, like all these places that are inch now, that means I'm saying that I do not want any moment to be transferred. I don't want any moment to be transferred. So the analysis is that those things are actually going to be the moment is actually going to be redistributed based on you engine it or not engine it. So thank you very much for staying to the till the end of the lecture. I'll see you on the next one.